Start recording. Okay. Well, welcome everybody to week 4. I'm excited to have you here. We have today with us as a guest speaker, Dr. John Cook, who is kind of the go-to expert on climate denial. So it's quite a pleasure to have him here with us to be able to talk about this subject. Dr. Cook is a postdoctoral research fellow with the Monash University Climate Change Communications Research Hub, and he is a cognitive psychologist that focuses particularly on the psychology of climate change denial. He founded the website Skeptical Science, which I will put that link in the chat for you at some point later, which is a pretty fantastic go-to resource for all of those questions that you get. You hear these questions of, well, what about the medieval warming period, and what about climate's always been changing, and all of those what about questions that you get. This is probably the best online resource that helps answer those questions for you and shows you the actual peer-reviewed science that goes in response to that. So I use this quite frequently in my communication. It's an excellent resource there, and John is the primary author that put that up. Also the primary author on one of the most important studies that quantifies the scientific consensus on climate change. You've heard the 97% number out there a lot before. And his research study is one of the first and most important ones that really put that number to be quantified, and has been really useful for establishing consensus there. So we are very fortunate to have Dr. Cook with us here today. And yeah, I think that's it. John, just to give you some context, we've got credit students that you see here. We've got another 30 or so webinar participants that are watching online. We usually get another 50 or so that watch it later, and there's 200 something that are signed up altogether. So there's a great variety of people engaging with the course, some for credit, some just for learning knowledge, kind of like we had it last year when you joined us then too. So I'll go ahead and turn it over to you, and thanks again for joining us tonight.
Thanks very much, Brian. Shared my slides, if that's okay.
Great.
And I'll jump into it. It all looks good to you?
Looks great.
Okay, so what I'm going to talk about is my research over the last 15 years into basically how do you fight misinformation? How do you, and particularly misinformation about climate change, which is the issue I've been most focused on. And I think that before you look into what's wrong about climate misinformation, it's a good starting point to look at, well, what do we know about climate change, just to kind of establish a baseline, I guess. And there are really only 5 key things that you need, like absolutely need to know about climate change in order to understand that we need to act on climate change. And you can summarize them with just 10 words. Firstly, it's real. We know that global warming is happening. We have warming indicators being observed all over our climate system, showing that global warming is happening. It's us. We know that human activity is the main cause of climate change. And again, we have human fingerprints being measured all over our climate system, which tell us that human activity is causing climate change, and also rule out the natural causes that have driven climate change in the past. The experts agree on these first 2 points. As Brian said, we published a study back in 2013 finding that 97% of climate scientists agree that humans are causing global warming. Actually, we published a paper last year doing an update, like we did an update of the methodology, and we found 98.7% of climate scientists now agree. But that paper got hardly any attention. I think it's old news now. Everyone's like, consensus, we already knew that. And that's a fair comment. But there have actually been a number of studies, and we weren't the first or the second or even the third study to find overwhelming consensus on climate change. The first was Naomi Oreskes back in 2004. So many studies, again, have found overwhelming scientific agreement that humans are causing global warming. And that's, I think there's a common theme already in my talk, which is that when you get multiple studies all coming to the same conclusion, that's when our scientific understanding is strong, and we can be confident that that our understanding is accurate. Fourthly, it's bad. We know that climate impacts will be bad and are bad now. We're already suffering climate impacts. So it's not just something that's going to happen to our grandchildren decades into the future. Climate change is happening now, but it will continue to get worse over time, particularly if we don't change course. And that leads to the last point, which is there is hope. We do have all the solutions we need to avoid the worst impacts of climate change. We just need to make that transition. So those are the 5 key climate beliefs, which come from survey research into how people think about climate change. And quite elegantly, you can sum them up in 10 words. So if you get on an elevator with someone and you want to quickly explain climate change to them, you only need 10 words to tell the main story. Despite the fact that we have this overwhelming consensus, there is a gap between public perceptions and the 97% consensus. See, even I need to update this, change that to 98.7. So, you know, I can't wag my finger at other people when I'm not even following my own advice. And so there is this gap, between public perceptions and scientific opinion. And it's actually worse than like 67. You think, oh, that's not too bad. But when I think the statistic was something like 10 to 15% of people say that the consensus is 90% or more. So very few people actually realize just how strong the consensus is. And one of the reasons why there is that gap is because the issue is getting more polarized over time. We've seen over the last 2 decades that people's opinions about climate change have been splitting apart depending on their political affiliation. The biggest predictor of what people think about climate change is not education or science literacy, it's who you vote for. And even more broadly than climate attitudes, trust in science has been getting more polarized as well. And amongst people on the left end of the political spectrum, it's been pretty level, but trust in science has been declining for decades amongst political conservatives. And actually, I kind of spoiler alerted this. I mentioned just a few slides ago that the biggest predictor of people's attitudes about climate change is political affiliation. And by a long way, it's way above other factors like education. Age, even age is above education. And what's happening there is the older people get, the more skeptical they are about climate change. So younger people are much more accepting of the reality of climate change compared to older people. Another interesting thing I find really fascinating is the 2 rightmost columns in this graph, political ideology and political affiliation. They seem like kind of the same thing. There's a lot of overlap between the 2, but conceptually they're quite different. Ideology is what we believe. Affiliation is what social group do we belong to? What's our social identity? And this is really telling us that fundamentally humans are social creatures. We identify with social groups, and that's deeply fundamental part of our psychology. And it means that when our tribe all believes one thing, it's really hard for us to go against that, because then we risk being ostracized from our tribe. And similarly, when a tribal leader says something, when our political leaders say something, that can be strongly influential amongst that group. So, just going a little bit deeper into why political ideology and affiliation is the biggest driver of people's climate attitudes. Scientists explain that using a term called solution aversion. And the way they explored that was an experiment where they presented 2 different messages to people. One message was, here is the science of climate change, and we need to solve it, and here is a solution. But what they changed in the message was the solution. For one group, they said, climate change is a problem. Here's the science. Let's solve it with a free market friendly solution like nuclear power. Then a different message was the same science message, but then saying, let's solve it with government regulation, having the government regulate the fossil fuel industry. What they found was those two different messages were pretty much equally effective amongst Democrats. But when they presented the two different messages to Republicans, there was a huge difference in response. They responded strongly to the free market friendly solution, but they reacted quite badly to government regulation as a solution to climate change. And what this tells us is ultimately climate denial is not about the science, it's about the solutions. When people don't like the solution, then they're more likely to deny that there's a problem in the first place.
John, do you mind if I jump in here? I'm just noticing something for the first time in this last one, that the Republicans' free market friendly solution is only barely lower than the response of Democrats' government regulation solution. I'm just finding that so fascinating that it's almost as high as Democratic response to a government regulation solution.
Yeah, it was the same science message, but the only thing that changed was the solutions. And so that tells us that if you frame a message in a way that doesn't threaten people's ideology, then it can be effective across the political spectrum. It can be nearly equally effective amongst Democrats and Republicans. Like, I don't want to make out that there is a fallacy in climate communication that if we can just find those magic words, the magic bullet, then we can magically solve all of society's problems. It's not quite that simple, because even if we did have our perfect free market friendly message or whatever, all that work can be undone by misinformation. So there are other complicating factors besides that. But still, the principle of making sure that our communication doesn't threaten a person's either their social identity or their political beliefs or their religious ideology. You know, there's lots of different ways that messages can turn people off. So it's about trying to avoid those triggers, and that's a key part of communication. Okay, moving on then. So again, I kind of spoiled myself, but the next thing I want to look at is, how does misinformation do damage? And I just want to talk about some research studies. And firstly, I want to talk about a study that tested what happens when people are shown different messages, particularly conflicting messages. Because just before I was saying, you know, we can have that perfect message, but what happens when people receive that perfect message and then also receive misinformation or conflicting messages? What is the impact from that? And there was an experiment done that tested what happens when people are shown a message communicating the 97% consensus. This was done back in 2017, so it's okay for them to use the outdated statistic. I'll give them a free pass. And also, they had done a lot of research into what are the most effective ways to communicate the consensus. Do you say 9 out of 10 or 97 out of 100 or 97%? Or and they tested lots of different ways of communicating the same idea. And once they had kind of, you know, honed, fine-tuned, and got a really effective way to communicate the consensus, they used that in an experiment. They also showed people misinformation that cast doubt on the consensus. And the misinformation was taken from a website called the Global Warming Petition Project. What this website does is it has a list of over 31,000 Americans with a science degree who have signed a statement saying that humans aren't disrupting climate. And the point of this website is to say, look at how many people have signed this petition. That shows that there's not a scientific consensus on climate change. In their experiment, one group was shown just the fact, the 97% consensus, and they got a strong positive effect because that has been shown to be a effective message. Another group was shown just the misinformation, and that had a significant negative effect. It reduced people's climate perceptions. And a third group was shown both. They were shown the 97% consensus, and they were shown the global warming petition project. And for that group, the two conflicting pieces of information cancelled each other out, and there was no net effect. And this has a big consequence for anyone involved in science communication or education, or just if you're trying to communicate facts to people, because it means that our facts can be cancelled out by misinformation. And we need to take that into account if we want our factual explanations to be effective, to make a difference. What's happening here is a lot like in those old Star Trek episodes where Captain Kirk, and sorry, this is this is like mid 20th century stuff. So I don't know if anyone in your class has ever seen classic Trek, but a storyline that would happen more than once is that you would have two copies of Captain Kirk, like the original Kirk and the evil cloned Kirk. And Mr. Spock had to figure out which was the real Kirk and which was the fake Kirk. And that's the dilemma that we find ourselves when we're presented with conflicting pieces of information, which is the fact and which is the myth. And when we are unable to resolve that conflict, then the danger is that we disengage and believe neither. So misinformation doesn't even need to be convincing or coherent or based on evidence or information. Just by existing, it can cancel out cancel out facts. But that dynamic also points to the solution to misinformation. If the problem is that people can't resolve the conflict between facts and myths, then the solution is we need to give people the tools to be able to resolve the conflict and be able to tell the difference between fact and myth. And a very useful framework for doing that, giving people the tools, is inoculation theory. This is a branch of psychological research that finds that just with vaccination, when you vaccinate people, you expose them to a weakened form of a virus, and that builds up their immunity so that when they encounter the actual virus, they're less likely to be infected. In the same way, when you expose people to a weakened form of misinformation, that builds up their cognitive immunity so that when they encounter the actual misinformation, they're less likely to be misled. So let me give you an example of inoculation. This is an excerpt of the inoculating message used in the experiment I was talking about. It inoculated people against the global warming petition project by explaining how it misleads. And that's how you deliver misinformation in a weakened format, by explaining the techniques, the fallacies that the misinformation uses to distort the facts. So there are a number of ways that the global warming petition project was misleading. Because it was a web petition, there was no quality control, so there were a lot of fake names in the list. 31,000 seems like a big number, but there are actually millions of US science graduates. So it's a tiny fraction, less than 1% of the total number of science graduates. And lastly, because it was anyone with a science degree, almost all of the signatories had no climate science expertise. They were graduates in computer science or veterinary science or medical science or engineering, but very few actual climate scientists. What the researchers found was when people were inoculated before being shown the misinformation, then the facts were able to have a positive effect again. And so that tells us that, yes, facts can be cancelled out by misinformation, but if we essentially wrap critical thinking bubble wrap around our facts and explain how our facts can be distorted, how we can be misled, then our facts have a fighting chance to have a positive effect. So I might just pause there actually and see if there's any questions, because I've been monologuing for a long time before proceeding. Or should we just save all the questions to the end?
We do have a couple questions in the Q&A here. The first one I think you just answered. Is the petition just a blatant lie, or the number is actually true? I think we got that one. And then Nate, hey Nate, how do we communicate about climate without threatening someone's social beliefs or ideology, etc.? When fossil fuels play a large role in belief, identity, social status for a lot of people. I struggle with the tell all the truth and go after the bad actors, industries, versus don't threaten people's priors when it comes to FS. Not sure FS.
Fossil fuels?
Oh, fossil fuels. Thank you. Yeah. So
yeah, I mean, that's a really good question, and it really depends on context. Who are you talking to? Your relationship with them. What is their identity? What is their background? And the general principle, I would say, is find out. Like, talk to them, understand them before you talk at them, or don't ever talk at them. But start by trying to understand where they're at, and try to find common areas, like commonly held values. And that can be a really good kind of foundation on which to talk about the issue. So rather than go straight to those triggers, those threatening, talk about things that might threaten their values, instead find shared values that you can have a positive, constructive conversation about. That all sounds great in theory. Actually doing it in practice is hard. And then the other question is, how do you respond to misinforming arguments? And again, I think that having a two-way dialogue can help with that. So rather than trying to be ready for that killer debunking statement when they say something, instead have a more relaxed conversation with them about their beliefs about that myth, trying to better understand why do they believe it, what are the assumptions behind what they believe, because often they might just state a talking point, but try to pull that apart. What are the assumptions and the conclusion, like almost like deconstructing the argument, because often you'll find that people believe something, but they haven't thought through what all the different assumptions, because there might be a problematic, unstated assumption behind a conclusion. I'm going to probably get into that in more detail further down in the presentation, but generally I think empathy and dialogue are ways to approach these kind of conversations. And curiosity, like genuine curiosity. Definitely not ridicule, though.
That's right. Good tip. One more, John, and then we can go on after this one. Chris asked, you said political affiliation was a key indicator of denial. Have there been any studies about religious affiliation? Yeah,
religious affiliation does correlate with climate beliefs, but my sense is that it's not, the religious ideology is not the main driver there. It's more because religious ideology also is strongly correlated with political ideology, like particularly in countries like Australia and the US, just to pick one religion, like evangelical Christianity is strongly correlated with political conservatism. And so you will find that evangelicals are more likely to be dismissive of climate science, but it's not necessarily because of their evangelical beliefs. It's because of the political conservatism and how that social group, and to a lesser degree ideology, is dismissive of climate change. So yes, yes, there is a link, but it's not as strong a link, and there's a logic to that, right? Because if solutions aversion, that not liking the solutions to climate change is the driver of climate dismissiveness, then that's a political ideology thing. That's not a religious idea. That's not driven by religious ideology. Whereas science denial to do with like evolutionary theory, that is much more organically linked to religious ideology. So you can have different science denial across different topics being driven by different ideologies. All right, so I want to drill a little bit down further into inoculation because there are actually different types of inoculation, and it's important to understand the difference. And firstly, I wanted to talk about logic-based inoculation. Now, the experiment I just described before with the inoculation and the global warming petition project, that was it was led by Sander van der Linden. I think he was at Princeton at the time during his PhD, and also with some of my colleagues at George Mason University and some scientists at Yale University. So it was all US scientists doing this experiment. At that time, I was doing my PhD in Australia, and I didn't even know this experiment was happening, but I was doing an experiment almost exactly the same. It was a case of, two scientific groups just moving in parallel paths in complete ignorance of each other. I was also, even using the same misinformation, I was running an experiment where I was showing people the global warming petition project. This was halfway through my PhD. Actually, the reason why I was looking at consensus was because my first experiments were all about really highfalutin climate concepts like greenhouse effect and solar activity affecting climate. And I found that people just weren't getting it. and that made my experiment results kind of weak because people were just having trouble understanding it. So I was like, okay, I need something simple and basic. I'm going with consensus. And so I did an experiment where I showed misinformation about the consensus. And this was what happened when people were shown just misinformation. The horizontal axis in this graph is political ideology. So the more to the right people are, the more right-wing or conservative they were, and more to the left, people are more left-wing. And the dotted line here is no change in climate perceptions. Anything underneath that means the misinformation had a negative effect. So what that tells us is climate misinformation has a disproportionate effect on people who are politically conservative, or it's more influential on people who are politically conservative. That's not to say all misinformation is. All I found was that misinformation about climate change is more effective or damaging with people at the politically conservative end of the spectrum. And what this tells us is that climate misinformation is polarizing. When misinformation washes over a society, people's beliefs split further apart and become the public become more polarized. In my experiment with a different group, I showed them an inoculating message before showing them the misinformation. And there was one significant difference between my inoculation approach compared to Sander van der Linden's approach. I didn't mention the global warming petition project at all. Instead, what I focused on was explaining one of the misleading techniques in the misinformation, fake experts, which is using people who convey the impression of expertise, but don't have the actual relevant research expertise. And then I used tobacco as an example of the fake expert strategy. What I found with this blue line here was when people were inoculated before being shown the misinformation was neutralized. There's a slope to the line, but statistically it's a flat line. basically the misinformation was neutralized across the political spectrum. And what this tells us is that whether you're liberal or conservative, nobody likes being misled. So explaining the technique used to mislead can neutralize misinformation, even polarizing misinformation like climate misinformation. And so that means that explaining the techniques of misinformation is a key part of building public resilience against misinformation. And so I found that a very useful framework for explaining the techniques of misinformation are the 5 techniques of science denial, originally proposed by Mark Hufnagel. Then I came up with an acronym to remember it because I have very bad memory. And so using the FLIC acronym I found a very handy way of remembering these 5 main techniques found in misinformation. And let me just quickly go through the 5 briefly. Fake experts is the example used in the Global Warming Petition Project. And in everyday life, we don't accept that if it's an issue that matters, we don't want someone who doesn't have the relevant expertise. So we wouldn't want someone performing heart surgery without the relevant expertise. Why, therefore, would we want people who have no expertise in climate change telling us things different to what the experts are saying? And the petition project is actually, Van der Linden tested a bunch of different climate myths, and he found this was the most potent one in reducing people's climate perception. So it's fake experts are very effective. And I think part of the reason is because it's a social type of fallacy. It's about people. And like I was saying, humans are social creatures. Social arguments are effective. But we've even seen the same thing being used during the pandemic. The Great Barrington Declaration was this petition arguing against all the health measures that the scientific community were proposing, like social distancing or masks. And they were arguing against those things, and they would just come up with a list of people to convey the impression that there was no consensus on mask wearing or social distancing. It's a go-to strategy, and it can be quite effective in persuading people. Logical fallacies are arguments where the conclusion doesn't follow from the premises. And just a quick primer on that, any argument has that structure, a series of starting assumptions or premises leading to a conclusion. If the premises don't logically lead to the conclusion, then the argument is a logical fallacy. So here's just a basic version of a logical fallacy. I have blue eyes, therefore I know quantum physics. The premise is I have blue eyes, and the conclusion is I know quantum physics. The conclusion doesn't follow from the premise. Just because you have blue eyes doesn't automatically convey expertise in quantum physics. We see this argument in climate misinformation a lot. And this is actually one of the most common arguments. And I think even, Brian, you mentioned it at the beginning. Climate has changed in the past, naturally, before humans were around. So what's happening now must be natural as well. And that logic is the same as arguing that people have died of natural causes. So someone who's obviously been murdered must have also died of natural causes. I need to have a less violent example. The other one is, I think that the argument goes, people have died of natural causes before cigarettes were invented, therefore cigarettes can't kill people now. But that one's not good either. I'll find a good one sooner or later. The third technique of denial is impossible expectations, which involves demanding impossibly high standards of proof from the science before acting. And here's just kind of an example of that, an extreme example of that, which is scientists don't give exact values. They give a range of values when they're estimating, they're taking measurements or they're estimating results. But often people will demand an exact number from the scientists. That's not how science works. So it's demanding an impossible expectation from science based on really a misunderstanding of how science works. And the analogy here is that scientists might not know exactly when the bad thing's going to happen, but they know it's going to happen. And so therefore we need to act. The fourth technique of denial is cherry picking. You know someone is cherry picking when the conclusion they come to from just a small bit of data is different to the conclusion you come to when you look at all of the data. For example, what is my example? Oh, that's right. I spent a lot of time making this animation, so I'm just going to show it because it was a lot of work. But the idea is, imagine being on a sinking ship and as the bow is rising, arguing, well, we can't be sinking because I'm actually going upwards. That's not looking at the big picture, which is that overall, the boat is going downwards. And we see cherry picking in science denial all the time, looking at select pieces of data while ignoring the bigger picture. Here is a common example in global warming. When you have what scientists call a noisy signal, in other words, the data is going up and down quite violently. When you have that, even if you have a long-term warming trend, it's possible to find any short period where it looks like the trend is flat or even going down. And so that means that over the last, I guess we're at 5 decades of global warming now. I need to update this graph. Over the last 5 decades of a long-term warming trend, you can find any short period during the whole period where it looks like the global warming trend is flat. And the interesting thing is 1998 was an exceptionally warm year. You can see it there, see how warm it was there. And so after 1998, because it took until about 2007 before it got warmer than that, over the 1998 and then the following years, a growing argument was global warming stopped in 1998. It was just cherry picking that short period and ignoring the long-term trend. The funny thing was that myth basically withered on the vine. It just stopped in 2016 because we had the hottest year on record in 2014, and then that was beaten by 2015, and then that was beaten by 2016. So after 3 hottest years on record, then global warming stopped in 1998 was no longer viable. And 2016 was so hot. But it was so hot in 2016 that I'm not sure that we've actually gone past it since. So now they're arguing that global warming stopped in 2016. They're dusting off the old argument and just changing 1998 to 2016. The last technique of science denial is conspiracy theories. When there's an overwhelming scientific consensus, when the community, the global community of scientists all agree, and you disagree with them, there's only 2 ways to explain that. Either all of the world scientists are accidentally wrong in the same direction, or they're all conspiring to deceive us. And that's where climate deniers go. They assume that climate scientists are trying to deceive the public. And conspiracy theories take different forms. There's kind of extreme, silly versions of them. But conspiracy theories can have really dangerous real-world societal effects, as we saw just over a year ago. Now, so that's a summary of the 5 techniques of science denial, or FLIC, which is a good way to remember them. but actually it's just the tip of the iceberg. And this is where it gets challenging, because while these 5 techniques of science denial are really categories of different rhetorical techniques, and there are many different fallacies and traits of conspiratorial thinking and other rhetorical techniques that are used to distort the facts. And so really, to build public resilience, to inoculate ourselves against misinformation, we need to become familiar with all of these different techniques, and not only become familiar with them, but actually internalize them deeply enough that we can spot them in the wild when we see a misinforming argument on TV or on social media or in a conversation. And that is a big communication and psychological challenge, and something I've been grappling with and working on for the last few years. I might just pause there, and in case there are any more questions.
I do have a couple of questions in the chat or Q&A, but students, panelists, give you guys a chance first. Questions for Dr. Cook that you want to ask?
I guess I was trying to understand how you would inoculate prior to exposure to misinformation. In that, I'm trying to understand, you would almost have to have seen the misinformation and prepare the inoculation, if you will, before you inoculate, if that makes sense.
Yeah, that's really hard to do. We actually tried it once during the pandemic. I forget the details, but there was, I think we were anticipating a specific argument that might happen. I think it was in Georgia, because there was something to do with the numbers, and we guessed that the misinformation might take a certain form, and we were wrong. So I think trying to guess what future misinformation might be is not very productive and probably a waste of time. But instead, I think a better approach is general inoculation against the techniques used to mislead. And that's really what logic-based inoculation is. It's not about, here is a specific myth, but here is a technique used. And let's look at some real-world examples, or even just silly examples like my little boat animation, as a way to become more familiar with those techniques. And then that's not the magic bullet that will help with everything, because sometimes you do need background knowledge to identify a myth, but it can help you spot the red flags of misleading arguments, and at least can put you on guard against when you see something that might be problematic, when it has a telltale technique in it. So, but one other thing, last November, we published research using machine learning to detect climate misinformation. And in the misinformation research field, that's called the holy grail of fact checking, being able to automatically detect misinformation. It's really difficult to do because, as you said, you don't know what the future myths are going to be. With climate change, it's a little different, because the myths that we're hearing in 2022 are the same myths that we heard in the early 1990s. Climate misinformation is remarkably static, and the same arguments, they're often described as zombie arguments, because they just keep coming back and just persisting for decades. Like we're now three plus decades of the same types of arguments. So you can inoculate against climate misinformation because those arguments will come back again. But generally, I think that this logic-based approach, in other words, building people's critical thinking, is a more generalizable approach that not only helps against climate misinformation, but can help people to spot misinformation across any topic.
Peter
Any
asks
questions?
in the chat, the Yale Climate Communication Project indicates there's been a movement away from climate denial over the last decade. What's driving that shift?
Yeah, our machine learning research found the same thing. Basically, once we had trained our machine to detect all the different types of arguments, we then put 20 years of climate misinformation into it to build this 20-year history. And what we found was this systematic transition from science denial to solutions denial. In other words, they stopped arguing. Remember those five key, those five key climate beliefs that I showed at the beginning? It's real, it's us, it's bad. The experts agree, there's hope. In our machine learning research, we found 5 categories of climate misinformation. And they were, it's not real, it's not us, it's not bad, can't trust the experts, there's no hope, or the solutions won't work. So it was kind of the opposite world, the bizarro world version of the 5 climate beliefs. In our paper, we actually called them the 5 key climate disbeliefs. We found the transition from it's not real, it's not us, it's not bad, to solutions won't work. And we hypothesized that because science denial is becoming more untenable as the evidence builds, as more and more data is being collected, confirming that it's real, it's us, and it's bad. It's just not tenable, it's not convincing. It's becoming less effective amongst the public to argue against science. So instead, they argue against the solutions. The result is always the same. The conclusion of any of these arguments is, it's not real, therefore we shouldn't act. It's not us, therefore we shouldn't act. The solutions won't work, therefore we shouldn't act. It's always the same conclusion. They just use different arguments towards that. But it's always about delaying climate action and maintaining the status quo.
There's another interesting one from Drew here. Prior to the invasion of Ukraine, the US announced Russia would use specific misinformation to justify what they were doing. Was this an example of inoculation?
Probably yes. It sounds a lot like inoculation, and it's smart. There is very common playbooks with these kinds of, like whether it's a war or an election, there is these patterns of misinformation. And so you can inoculate people against these misinformation campaigns by getting in front of them. And they are common. In fact, there is a game called Harmony Square, developed by Sander van der Linden, who ran that experiment at the start of my talk. Harmony Square was done in collaboration with the State Department, the US State Department, to inoculate people against misinformation targeting elections. And they were basically trying to build public resilience in order to preserve democracy. I went to a misinformation conference in Singapore a few years back. And that was really fascinating because most of the conferences I go to had been in the US, and it's a very kind of US focused sort of themes and research. In Singapore, it was researchers from everywhere, from the Southern Hemisphere, like from Latin America, Australia, many Europeans and Americans. And I was seeing the same thing happening everywhere. Since 2016, the penny had dropped and everyone around the world had realized that misinformation can play a strong role in influencing the outcomes of elections. And so it was like a boom time for misinformation, particularly around elections. And so many of the talks there were about how do we protect the integrity of our election in this European country, or in Asia, or all around the world. I forget your question is. I've been meandering.
That's okay. That's a lot of facts. I've got to follow up on that. Then, what about the misinformation? And when we hear a lot about misinformation related to American beliefs. And that's in part sort of the focus because most of the people in the course are coming from that background. But what do you know, or what can you tell us about misinformation on climate change from elsewhere outside the United States?
We're just in the process of doing that now. Like we're collecting media articles from all around the world. It has to be English because our machine learning model was trained using English, and we're going to put it all into the model and then compare different countries and what are the emphases. So far, all we've done is compare the US to Australia. And there's one interesting difference. I mentioned this transition towards solutions misinformation. In the US, solutions misinformation is mostly about climate policy, arguing that climate policy will be harmful. It will raise prices, it'll destroy the economy, it'll hurt working families, basically arguing against climate policy. And a less common form of solutions misinformation is attacking renewables. Wind kills birds, or the sun doesn't shine at night, so therefore solar is unreliable. Those kinds of arguments. But it's policy way up, much more prominent, and then renewables is down here. In Australia, it's reversed. Renewables is the main theme of misinformation, and policy is much less. This is just a preliminary result, so we haven't really explored why this is the case. But my speculation is that there have been more attempts to get climate policy through Congress in the US. There's a long history of that, whereas Australia, not so much. Really, there was the carbon pricing in, when was that, 2013, I forget the year, but less than a decade ago, but not really much else besides that. So instead, there's a different focus. So we're just on the edges of that, but it's a really good question because understanding those differences means responding to misinformation in different countries is probably not a one size fits all. You need to tailor it depending on the emphasis.
We have some other questions, but why don't we go ahead with your presentation? We'll come back around.
Okay, great. Yeah, I don't. What time do I need to stop? Because I realized it's 4 to 11.
Scheduled today, so I would say as long as you feel like you have time to give to us. Our class technically goes till 9. We won't go that long.
Well, I can go over. So you let me know when you're sick of hearing from me, and then we can stop then. So I've talked about the research establishing the efficacy of inoculation in the lab. And this is one of the big things about climate communication research. We can run our lab experiments and get all these exciting results and okay, this is what we're going to do. But then, how do we actually pull this off in the real world? And there are 3 big ways that trying to scale up inoculation so that it actually shifts the needle in the real world is really difficult. The first I've already talked about, the idea that internalizing all those different fallacies in the Flick taxonomy is hard. It's critical thinking, and critical thinking is hard. Our brains are hardwired for fast, immediate gut level responses. We almost all of our thinking is what psychologists call fast thinking. Just these instant responses. And while it is possible for us to stop and do slow thinking, critical thinking, reason through complicated problems, it's hard because our brains are hardwired for mostly fast thinking. So that's a very fundamental psychological challenge to inoculating people against misinformation. Secondly, there is a structural problem. Even if I come up with the perfect inoculating message, how do I get that to communities that are usually in echo chambers that are only listening to themselves? And I will, I'm on Twitter. I've got, thousands of followers on Twitter, which is probably not much, but for a scientist, it's not bad. But I'm the type of people who need to be inoculated against misinformation are not the same people who follow me on social media. how do we get our inoculating messages to the people who most need it? And the third challenge of inoculating the public is social. As I've said before, humans are social creatures, and climate change has become very tribal, given that political affiliation is now the biggest driver. And so how do you overcome these tribal instincts when you're trying to inoculate people? Now, I really had no answer to any of these three challenges over the last 10, 15 years I've been working on the issue. And then I think purely by accident, certainly not any cleverness on my part, I kind of stumbled into a potential solution to all three of these challenges. And that solution is games. I was actually at a misinformation conference in Washington, DC, and just happened to meet a game developer in a workshop. And we just got talking and then started collaborating. And the final outcome of that meeting was developing a critical thinking smartphone game. We called it Cranky Uncle. The idea of it is that you are mentored by a cranky uncle on how to become a science-denying cranky uncle yourself. But really what he's doing is explaining Flick to you. He's taking you through all the different techniques of science denial. He explains how each different technique works. It uses examples to make it entertaining and engaging. And then here's the important bit. It gets you practicing critical thinking. It gives you examples of misinformation, and you have to identify what is the Flick technique in this specific example. And the more you spot examples, the more points you get. And as you collect cranky points, you level up, and each time you level up, your mood gets a little bit crankier. And so it uses all those gameplay elements to motivate people to keep playing, get further into the game, because the further they get into the game, the more inoculated they get against misinformation. And importantly, the more they practice critical thinking, the more spotting fallacies changes from a slow thinking, critical thinking exercise to a quick thinking reaction. You're basically turning critical thinking into a easier, quicker response. Whoops, I forgot that I put this in here. We made a video when the game came out to just explain the game. And one thing we described was the idea that you're trying to replace all these potentially bad mental shortcuts that make us vulnerable to misinformation with good mental shortcuts, which is spotting fallacies. And then I just was trying to be clever by taking the NRA talking point and trying to apply it to critical thinking. So the second challenge of, and so that's an explanation of how games can help overcome that first psychological challenge of critical thinking being hard. The second challenge is, how do you reach these siloed communities? And what I realized even before the game came out, while I was developing it, was I was talking to a lot of climate scientists about the game, and climate scientists usually teach climate classes at college. And it really surprised me how enthusiastic they were to use the game in their classes. And so when the game came out, the next month, I then put together a teacher's guide to Cranky Uncle to make it easy for teachers to, or to make it easy for them to use the game in their classroom. What we found very quickly was teachers, this is really out of date, actually. This is a year old, this graph. Sorry, I'm really annoyed with myself for not updating it. But what we found is the game is now being used in 40 different states, and hundreds of classrooms around the US are currently using it. So this is a much more furiously filled up map nowadays. And so it means that the game is going into all these classrooms in red states and blue states that otherwise would have no way of reaching these people. And so I think that classrooms are one potentially really powerful way of cracking echo chambers and reaching these silo communities. The third challenge of inoculating the public is how climate change has become so tribal. And I've talked about how this social identity can have this quite negative effect in making some parts of the population dismissive of climate science. But tribal instincts can also be used to motivate people for good outcomes. And this is something we've only started to toy with. The idea of having cranky contests where you have people in one group compete against another group to see who can get the most cranky points. And what that does then is it motivates people to play the game, from tribal instincts because they want their tribe to beat the other tribe. But their tribal instincts are motivating them to become inoculated against polarizing climate misinformation. So it's taking a potentially negative instinct like tribalism and using it for good. We've only just started playing around with this, and we need to really update. We're continuing to revise the game, and we're hoping to get contests as a greater part of it. In fact, right now we're working on version 3 of the game, and one thing we've talked about is having a classroom sign up for the game, and then having all the students in the class sign up, and then having a leaderboard. So you just have your classroom and all the individual students. So that's not so much group versus group, but we think that kind of leaderboard could also motivate players to get further into the game, or could start fights in the classroom. We don't know. We'll see how it goes. That's all I wanted to talk about, but happy to answer more questions now. And also, you can grab more information. Feel free to follow up if you want to email me or check out the Cranky Uncle website. And I have a lot of videos about critical thinking on YouTube too, so you can check those out. I'll leave this up for a few more seconds while I'm answering questions.
I had in the course. I'm going to create an extra credit exercise. The credit students, you guys can find that and play a game for extra. Haven't had that class yet, and it is a lot of fun. My kids love the Cranky Uncle game, but I don't have many games on my phone, so whenever they grab my phone, they want to play the Cranky Uncle game. Panelists, students, give you guys a chance to go first, and then if you don't ask me, I'll jump to the Q&A section here. Let's jump in. Anna, tell us about the amount of funding invested in this information.
Sorry, you broke up then, Brian. The audio was a little bit, I didn't quite get the question.
You hear me now?
Yes.
Yes.
If you could repeat the question.
Juliana asked, what can you tell us about the amount of funding invested in this information and the source?
Yeah, so Bob Brule from somewhere in the Northeast, he has done some really good research into funding of conservative think tanks, which are one of the most prolific sources of climate misinformation. And often they generate it and then it gets amplified and disseminated. He found that in total, billions of dollars have gone to the conservative think tanks who produce misinformation. every cent of that might be specifically for misinformation, but and so that's kind of one of the things is that often there's a black box in terms of tracking where the money goes, but in total, money from corporate interests number in the billions going to the organizations that produce climate misinformation. So I'd say that it's a safe assumption that climate misinformation is the most well-funded misinformation campaign probably in history, certainly dwarves tobacco misinformation by a long way.
Which certainly makes sense when you consider the size of the pocketbooks of the companies with a vested interest in not changing their business model, right?
It's money well spent because they maintain the status quo, and they are evolving their misinformation. Greenwashing is becoming a more subtle form of misinformation where the fossil fuel companies sell themselves as being environmentally friendly. A good example, I think this is brilliantly evil, is the term natural gas. That was developed by PR companies, and studies have shown that when you call it methane gas, people are like, well, that doesn't sound too good. When you call it natural gas, they're like, okay, sure, that sounds environmentally friendly. It's a fossil fuel, but they're selling it as a bridge to environmental action. And here's the big irony. In Australia, at least, like we're a month or two away from our federal election, the Conservative government is selling gas mining or gas projects as their environmental policy. So the whole natural gas thing is it's been brilliantly sold as not damaging to the environment.
Here's a great question. I have a response on this. How do you explain 3 who deny change? What's their motivation?
Actually, it broke up again, but I just found the Q&A window, so I can read it myself. All right, so that's a really good. So Naomi Oreskes, as I mentioned her earlier, is doing the first consensus study, and she's the world expert on understanding these people because her book Merchants of Doubt looked at the individuals, these 3% people who cast doubt on climate change and how they were the same people casting doubt on acid rain or even the health impacts of smoking. They have this history of using the same techniques across multiple topics. And so I asked her what drives them, like she knows better than anyone. And her answer was malignant narcissism. So obviously every individual is complicated and different, and some will be motivated by money. Others will be ideologues, pure ideologues who are motivated by ideology. But generally what you find across these 3% of people is because they are the tiny minority, they stick out, they gain infamy. They get, like we published a study in 2014 surveying the scientific community and found that the contrarians, the 3%, they got a lot more media attention than the non-contrarians because they're the ones who stick out. Who cares about the guy who disagrees with everyone else? I want to hear about the guy who's saying something different. It's that kind of thing. They often get fated by industry or by contrarians or contrarian communities. So it's kind of a claim to fame in a way. And so for them to switch to agreeing with the consensus kind of removes their raison d'etre. It's their kind of their whole sort of their whole stick, I guess. I mean, but again, that's not the one answer because people are complicated and individuals can be motivated by different things. Sorry, do you want me to answer John Cluett's question about blowfish? All right, so one of the fallacies in our Flick taxonomy is red herrings. A red herring, originally it came from, or at least apocryphally, it came from the idea of you have sniffing dogs trying to track somebody, and the person who's getting chased would throw down these red herrings, these very smelly fish, to throw the dogs off the scent. So that's where red herring comes from. In an argument, a red herring is any point, any premise, just saying something that will distract people from the main point of the argument or distracting them from the conclusion. So it's like I have blue eyes, therefore I know quantum physics. Having blue eyes is a red herring. It's got nothing to do with knowing quantum physics. And you often see that in arguments. People will just throw something in there, throw in a grenade that has nothing to do with what the argument's about, but it just derails the argument. So you need to watch out for red herrings. Blowfish fallacies are a subgroup or a type of red herring. And I mean, I kind of came up with this for an article I was writing for the conversation. I don't know if it was a good idea to do it or not, but it seemed fun at the time. And a blowfish fallacy is when science deniers take a very tiny part of some research methodology and blow it out of proportion to distract people from the research results, even though this tiny little thing that they're obsessing about has no impact on the final results. We saw this with Michael Mann's hockey stick. So in 1988, was it 98? I think it was 98. In 98, Michael Mann published the hockey stick study, finding that over the last 1,000 or so years, climate change didn't happen. There was only small climate change until the industrial era, and then it suddenly jumped up. So you have this hockey stick shape to the temperature data. And it was a simple graph that told a compelling story and therefore was very effective. And therefore it got attacked a lot. And they basically used blowfish fallacy to attack it. They looked at all these little very obscure statistical techniques and nitpicked aspects of the statistics which had no bearing on the final results. But they used those critiques to argue that the hockey stick was invalidated and should be thrown out or was unreliable. And subsequent research using completely different statistical techniques to Michael Mann got exactly the same results. It was an example of blowfish fallacy. I've also experienced it a lot with our 97% consensus study. So in our study, we did content analysis. We read thousands of abstracts of climate papers, identifying which abstracts agreed with the consensus of human-caused global warming, which abstracts disagreed. And from that, we found 97% agreement with human-caused global warming. Then we asked all the scientists who wrote those actual papers to categorize their own papers. So completely independent of our analysis, we said to the scientists, look, you're the experts on your own papers. Does your paper agree or disagree with human-caused global warming? And then we collected the survey data. The result was 97% consensus. So doing it independently, we got 97%. All the criticisms of our paper when it came out, and there were hundreds of articles were published criticizing our methodology. It all focused on that first type of analysis and saying there was a flaw in this part or there was a flaw in that part, therefore the 97% figure is invalid. Every single criticism ignored the fact that we used an independent method to get to the same result. And so that's another example of blowfish fallacy, focusing on minute methodological nitpicking, which don't influence the final result. Yeah, as for the Supreme Judge thing, I've kind of got a bit of distance from that kind of stuff after moving back to Australia. And frankly, that's a relief, because when I think about the Supreme Court, it's just so painful after the last 5 years, what's happened there. So anyway, do you want me to answer Drew Harvey's question? Okay, so how can society become more accepting of the positive opportunities from transitioning away from fossil fuels? I think that is actually one of the key strategies to building support for climate action and transitioning to renewables, is telling the positive stories. I didn't mention it in my talk, but the one thing that misinformation researchers say is the golden rule of debunking is you fight sticky myths with stickier facts. So you want to dislodge those myths with facts, but you want to make those facts as compelling and as sticky and concrete and simple and engaging as possible. And often telling stories is the way to do that. In the case of communicating the need for climate action and countering climate misinformation, particularly these solutions-based misinformation, which we're going to see more and more of, I think that telling those positive stories of the co-benefits that come from climate action are really important. Talking about the economic benefits, the health benefits are really important. And in fact, talking about climate change through a health framing is one of the most bipartisan ways of talking about climate change. It works equally well across the political spectrum. So I think that identifying those positive opportunities from climate action and then communicate, and there's lots of success stories. So we just have to find those success stories and tell those stories repeatedly. And repetition, we just have to be persistent. There's one of the, there's a famous quote by Frank Luntz, who is the Republican strategist who came up with the strategy of casting doubt on the scientific consensus. And it was a good strategy. It's been very effective in confusing the public. One of his famous quotes was, to get a message across, you say it again and again and again and again and again and again until you're sick to death of saying it, and only then people are hearing it for the first time. Scientists don't like repeating themselves. We get bored. We're always at the edge of knowledge trying to find the next thing. We don't like saying that thing that we found in a paper 10, 15 years ago. We want to talk about our new research. I'm sick to death of talking about the 97% consensus or the 98.7% consensus. But it's important that we are persistent and continue to repeat these simple messages that the public need to hear. And so I think that we need to find these positive opportunity stories and then tell them, be very persistent and repetitive in communicating them to the public.
No.
Yeah, sorry, it's still breaking up, Ryan, but I'll go to Scott's question if that's okay. Any ideas on addressing people who say, don't confuse me with facts, my mind is made up? Yeah, so you need to recognize that often you're not going to change a person's mind no matter what you say. If someone is dismissive of the science, then they are usually, well, they are distrustful of any information you provide and any sources that you rely on. So that means that if someone distrusts you, it's pretty hard to crack that wall. You still, it's still worth trying using some of the approaches I talked about earlier, such as empathy and two-way dialogue and finding common ground. But I think we need to be realistic that often you're not going to change a person's mind if they're dismissive about climate change. When I'm, or not when, back when I used to give public talks with real people in real rooms, particularly public talks where there might be climate deniers in the audience, and they would ask me questions, and I would answer their, arguments that had misinformation in them, and I would be debunking their myths. I would be fully recognizing that the odds of me changing that person's mind is small to nothing, but the way that I approach answering them is often thinking about everyone else who's watching that exchange, and speaking for their benefit. So I would explain how the misinformation is misleading in the hope of inoculating everyone else who's watching the exchange. And so what that does is I get less frustrated because I'm not banging my head against a brick wall trying to change a person's mind whose mind can't be changed. And that allows you to be a bit more calm, rational, talk in a non-emotional way. And how we talk can often be as important as what we say.
I switched over here to my laptop, so I got my audio coming on the laptop. Hopefully that's okay.
Sounds good.
Sorry, I guess I'll have to check out my webcam here and see what's wrong with it. I love that last comment, John. That's just so critical. And you guys might find yourself, now that you're taking a course on climate change, you're learning more about it, you might find yourself tempted to be drawn into those Facebook conversations. And I think those last words from Dr. Cook there are particularly important to realizing that, yes, it's important to respond to misinformation, but realize you're not really responding to the person who's got the zombie arguments that they just keep throwing up there. Like you're responding to the audience that's watching the conversation take place as a more helpful group to think about as your audience. And then another comment I was going to say something on before, you mentioned about health impacts and using health as a communication tool. Last year we had Ed Maibach, who of course I know you know very well, John, talk in this class, and I've got his recorded lecture. So credit students, you guys get to watch his recorded lecture from last year during week 8, I think. And that he did a fantastic job talking about how we can use health communication as a way to bridge the gap in talking about climate change. Oh, and then one other thing, Drew put in the chat here about how often our communication is about how climate change is really bad and we should be afraid. Perhaps we should think about a different way of messaging. Climate change is an economic opportunity. It reminds me, do you remember when Joe Biden was running for president? And he would say things like, when I think about climate change, the first word that comes to my mind is, you guys know? This was like a standard line that he used. Anybody want to guess what he said? First word that comes to my mind is jobs. Yes, that's right, Kevin. This was his go-to line. And that was extremely deliberate on his part, exactly for the reason that Drew put in there, that's a way of reframing this of job. And the reality is that there are jobs. There's more solar jobs in the United States right now than there is in the fossil fuel industry. That's a great line that it's talking about, John is talking about countering with stickier points. That's a great sticky point line that people remember and that resonates with things that matter to them and connect with values that are important to them. All right, any last questions? Well, thank you, John, so much. I really appreciate you taking the time to be with us tonight. I always love this session because it's just such a fascinating look at this question that sometimes makes us want to pull our hair out, or maybe for you and I, that's too late, but for others.
Well, why do you think, see?
Right, it's already all pulled out. Thank you so much for your time. Everybody else, we're going to end a little bit early today. Credit students, you guys hang on for just a minute. I just got a couple things I want to go over with you guys while I have you here. But everyone else, thanks so much for joining tonight. Good to see you again next week. We have Marinel Ubaldo, who is a Filipino climate activist, joining with us. And you are really going to enjoy her talking about global climate justice and the youth movement for climate action. And she is a youth leader in that movement. And it's going to be really great. We also have a pre-recorded interview with Elizabeth Wathuti that you will find in your SharePoint folder and credit students in Moodle. and she spoke before the UN Climate Conference in Glasgow this year and gave one of the best 6-minute speeches I've ever heard on climate change. So be sure to watch her recorded interview for this class as well, because she was just fantastic. All right, thanks everybody. Thanks, Sean. Any blessings on your work. All right. Sorry about the audio problem there. I don't know what the deal was, but I'll have to take a look at this this webcam and see what's going on. Okay, just a few notes for you guys, because I started typing this in an email. I'm like, I'm gonna have to see him in class. I'll just say something in class here. Let's see, on last week's quiz, number 4, I gave partial credit. I went back and looked at it. A lot of people got it wrong, and I see one confusing thing there. All the following are true about the Paris Agreement, except anyone who put, now that the US has joined, every country has signed the agreement. I gave partial credit for that one, because while it is true that every country has signed the Paris Agreement, we did talk about how there are 4 countries that haven't ratified it. And I can see how that might be a little bit confusing there. So I went back and gave some partial credit for people who picked that answer. So FYI there. Reminder on the class recordings, it's mandatory and graded to watch the recordings. I'm not talking about, I mean, the Wednesday night things are mandatory too, but the pre-recorded ones in Moodle, those are all mandatory. Those are graded, 10% of your grade to watch those. So make sure that you are watching those. And make sure it records that. So when you got to watch to the end and click, so I think it says submit. Is it submit that it says at the end? Okay, yeah. Make sure you click the submit button, and then it's helpful just to go back and look and make sure it did submit. So I think most of you that's working for, but just worth double checking. Reminder on the Flipgrids, also mandatory, also graded. And then one other thing that I wanted to give a brief mention of. So the last week of class, okay, here we go. Instead of a quiz the last week, we're doing a reflection paper. And I know you're not really wanting to think 4 weeks ahead now, but I'm saying it now because it might be helpful. You might find it really easy to work on this as you go and save you time later. The final reflection paper, basically it's just asking for like a 6-page synthesis of everything we're covering in the class. And this is kind of my suggestion on what that might look like. So what I'm thinking is like maybe a half page or so on each week. If you want to even divide it up and have like week 1, creation care theology, and then write a half-page sort of summary synthesis of that. Week 2, climate science and impacts. So I just kind of typed up some sample of what this might look like, put in some filler words here to get a sense for how long that might be. And then sort of ending with like a 1-page, like bringing it all together in one spot. What's the most important piece here? And then concluding with just a few personal reflections on what you learned at the end. You're welcome to forget about that until week 8 and do it then. Or if you find that like, hey, I just did week 4 this week, it might be really easy for me just to write that half-page summary of week 4 and have it ready for that end of the class section. Just bring it to your attention in case that's helpful now to do it that way. Does that make sense? Anybody have questions on that? Okay. Yeah, do reach out if you guys have questions. If you have questions on the quizzes, if you're looking at the quiz, I try to give helpful feedback on those so that you can see where the grade comes from. If you ever have questions on that, or like if you're looking at a multiple choice, and you're like, I really feel like that one wasn't fair. Like I picked this, I felt like, that, feel free to bring that up. I'm glad to re-examine questions, especially if you feel like it maybe should be looked at differently. So I'm glad to look at that and consider that. So let me know anytime you have thoughts or questions, or if there's anything that I can help you out with.
I actually have a question. Do we have class break?
Yes, we do. So the way the online, because this is with the online program, the way it works is that there's no breaks. It just goes the full 8 weeks. So for you unfortunate main campus students, sorry, you do have 1 class on the break. Anything else? All right, getting out early today. Woohoo!
What would it take? Question.